Trigonometric functions, part 5. All right, we were here in the last video, x equal 3 pi over 4 minus pi over 4, then x equal 3 pi minus pi 2 pi over 4 divided by 2, cancel by 2, so it will be x equal pi over 2. That's great. X equal pi over 4 is pi over 2 is a rejected value because it makes the denominator 0, and that's what we said. This is the vertical asymptote, so I don't take this value. Let's see what we have here. X equal minus 3 pi over 4 minus pi over 4. This means x equal minus 4 pi over 4, right? Minus 4 pi over 4, which is minus pi. Here I should take plus 2k pi, right? Because minus pi, it's out of the domain I'm working with, which is 0 to pi. In this case, we do what? In this case, we add for k equal 1. 2 times 1 times pi, it's 2 pi. So it will be minus pi plus 2 pi. So x will take this value, which is equal to pi. That's great. So we have x equal pi. This is the accepted value. X equal pi. Now, what I have to continue, right? I have to continue doing the table of variation. Doing the table of variation. This is the only value I got. From derivative equals 0, this is the only value I got. Let's do the table of variation. Table of variation is that x minus, from 0, sorry, to 2 pi. This is the only part we are working with. We have to remember, very important, that pi over 2 is a rejected value, horizontal, vertical asymptote, so it's pi over 2 here. I got pi, right? What else? We have to check the derivative, and we have to check the behavior of y. That's great. Again, this is the function, this is y. If we substitute pi instead of x here and here, cosine pi is minus 1, plus 1 minus 1 is 0, 0 over number, 0 over 1, actually it's 0, so it makes y 0. Also pi makes the derivative 0. We have these two values from the derivative, this value over here and this value, same sign outside, opposite inside. It will be positive outside, negative inside. Also we can check values. Okay, y goes from, simply we didn't do those, right? If we substitute x equal 0 also in y, cosine 0 is 1, so it's 2 over sine 0, 0, 2 over 1, it's 2. Same for 2 pi, so also it's 2. So it goes up from 2 up to plus infinity, because this is asymptote, plus infinity of this asymptote, goes back from plus infinity of asymptote to 0, and then goes up from 0 up to 2, This is the table of variation. When we do the table of variation, this means this is plus infinity and this is plus infinity. When we do table of variation, this means it's done, it's over. We did solve the number. Let's try to draw y-axis, x-axis. Okay, and we start putting the points. We got them. We got 0, 2, right? 0 abscissa 2 ordinate, 0 abscissa 1, 2 ordinate. This is important point. What else? We got 2, 0, 2 pi 0, I mean. 2 pi is 2 pi is approximately 2 times 3.14, so it's approximately equal to 6.28, right? So let's say 1, 2, 3, 4, 5, 6, 7. 6.28, a bit more than 6. This is 2 pi. That's great. What else we have? We have pi over 2, which is asymptote. Pi over 2, it's 3.14 divided by 2. The answer is 1.57. A little bit more than 1.5. This is a pi over 2. And at pi over 2, what do we have? At pi over 2, we have asymptote. So we have to draw an asymptote over here. Let me draw this asymptote in red instead of dotting it, right? What else we have? Sorry, we have pi. Pi is 3.14, 1, 2, 3, and a bit more than 3. So this is a pi. As you can see, a pi 0, pi abscissa 0 ordinate is a minimum point. That's great. Now it goes from 2 exactly up to plus infinity, from 2 exactly up to plus infinity to the left of the asymptote. It's something like that. When it goes more to pi over 2, it seems it's touching the asymptote, the distance approaching 0, but it's not 0. And this point here is the 2 pi 2. Now it goes down from asymptote plus infinity all the way down to pi to 0 to point abscissa pi ordinate 0, and then it goes up to this point. Okay, this is the drawing. Exactly, this is it. Now this is from 0 to 2 pi. If I want to continue again, as it here goes from 2 up to plus infinity to pi over 2, so we have to add to 2 pi over 2, right? Pi over 2, and I will get 5 pi over 2. I will get another asymptote, and it goes from 0 to that asymptote this way. This part is the same as this part, right? And from here, it goes down to minus pi, and it goes up. Okay? We don't need that. We need just the black one, which is enough to draw one period, and that will be great. All right, see you in the next video to do another example. Okay, then it's finished.